Alright, time for the solutions for the end of year review number 3, which is all about geometry. And I did try making this video already, but it crashed on me, which means I have to start all over. But some of the things are already marked on it, and so if you see something already marked, it's because I was already trying to do this. Anyway, if you're going to do an angle bisector, you need to take a compass and you put it on your vertex, and then you draw an arc that crosses both sides of your angle. And then you're going to put your compass center on each of those new intersection points, and using the same hole, draw arcs over here that overlap. You have to make sure you use the same hole for each one. And then you're going to put your compass, you're going to draw a line from your vertex through where those two just crossed, and that'll be an angle bisector. If you're going to construct a regular hexagon, you need to put a point on the edge, and then you're going to put a compass there. And you figure out what hole gives you the center, and then use that center, draw an arc to the edge. Then you're going to put your compass there, and again, figure out what hole gives you the center, and draw an arc there to the edge. And you're going to put your compass center there, and continue on with the pattern as you go around the circle. And if you did it correctly, these are going to be equidistant from each other. And you're going to connect up where they meet with the edge of the circle. And that'll give you a regular hexagon inscribed in a circle. If you're going to draw a perpendicular line through a specific point, it's just like doing the perpendicular bisector, except there's one step at the beginning. And you put your compass on that point that's not on the line, and then draw an arc that crosses your line twice. These here are going to be the points where you're going to put your compass center. You're going to put your compass center on each of those, and you're going to do the two overlapping arcs thing. Make sure you use the same hole for both of those arcs, and then you can draw a line that connects up where they intersect. And if you do that, it'll go through the point that's not on the line, and it'll meet with your original line at a right angle, which will be a perpendicular line through the point. Number 4, now it's time to draw some transformations. So a 90-degree counterclockwise transformation follows this function over here. You take xy, you switch the order, and you change the sign on your new first coordinate. So right here, w was at 4, 5. Change the order, 5, 4. Change the sign on the first one, negative 5, 4. And that's why w prime's right there. And you do the same thing for both of those. E was at 3, 3, so negative 3, positive 3 is where it's going to be a new spot. S is at 3, 4, so the new spot's going to be at negative 4, 3, and that's where all those come from. This translation, xy goes to x plus 5, y minus 2, means you're going to add 5 to all the x's, which is going to move it right 5. And then you're going to subtract 2 from the y's, which is going to move everything down 2. So if you go right 5, down 2, you'll get this shape here. Make sure you put the primes on those vertice names. And that brings us to 6, which is where things crashed. Anyway, this first part, you're going to reflect over x equals negative 2. X equals negative 2 is a vertical line through where x equals 2. And you just reflect over it. You just balance over as far left as it is. You're going to do that far right on the other side. So j is 3 to the left. So j prime is going to be 3 to the right of it. Z is 3 to the left. So z prime is going to be 3 to the right of it. After you have those, you can connect them up, and that one's done. But now you need to do another transformation. I'm going to do this one in blue just to show you the next one. Rotate 180 degrees. The function for that is xy and goes to negative x, negative y, which means you're going to just change the sign on your coordinates. So right now m is at negative 1, 2, so I'm going to go to negative 1. You're going to go positive 1, negative 2, and that's going to put m right there. So there's my m prime. Oh, double prime now because I've done 2 transformations. L is currently a negative 1 at positive 4, so I'm going to go to positive 1, negative 4, and that'll give me my L double prime. J is at 1, 4, so you can go to negative 1, negative 4, and that'll give me J double prime. And then Z is at 1, 5, so you can go to negative 1, negative 5, and that'll give me Z double prime. And I got one more transformation, which is going left 1 up 2. So if I go left 1 up 2 from M double prime, it's going to put it right there. And that'll give me M triple prime. L going left 1 up 2 will give me this guy here, triple prime on the L. And then J left 1 up 2 is going to put him right there. So there's J triple prime. And then Z left 1 up 2 Just going to put it right there, Z triple prime, and then you connect that up, and I totally forgot to connect up the blue one, but you get the idea. I just move the vertices of my figure, and it'll get me my new one, just like that. Moving on to the next part, we need to write down what transformations were done. Well, this one, if you can draw a line of symmetry through the shape, you definitely have a reflection. And this line right here is y equals -2 because it's horizontal. So this one is a reflection over y equals -2. This guy here has a series of multiple transformations. It's got 3. You notice the triple prime on it. And so there's a few things that you can do. What I'm thinking of doing right now is actually starting with a rotation. I can do a quick 90-degree clockwise rotation, 90-degree clockwise rotation. And what that's going to do is put it over here. And so B is going to be right here. And then A is going to be 2 to the right of that. And C is going to be 1 above it. So that'd be B, A, and then C. And now if I reflect over my x-axis here, it's going to end up right up here, and C is going to be in the same spot. A will be up there, B will be right here. You can kind of just picture this in your head. A's up here. This would be the double prime part. And now we're right here. Actually, these should be switched. A triple prime, and then C triple prime. And now, so that's a reflection. I think I could spell things. Reflection over the x-axis. And now we just have to translate right. And you just have to move right 1, 2, 3, 4 units to get to the right. So translate right 4 units. And that's just to get it to the right spot. So 4 to the right. Now it's time for a whole bunch of other stuff, which we're going to start by drawing the lines of symmetry on the figures. This guy here on the left is an isosceles triangle, which just has a single line of symmetry there. This is looking like a regular hexagon, which is going to have 6 lines of symmetry. 1 here, 1 there, 1 there. And then we're going to have them connecting the vertices. So this one has 6 lines of symmetry. This one has 1, this one has 6. This one's looking like we have 1, 2, 3, 4. So this one has 4. And then the circle actually has infinitely many. They just have to all go through the center. So yeah, this one has infinitely many. That brings us to number 11. What's the minimum number of degrees required to rotate the figure onto themselves? Well, there's a little handy formula to get you that. You just take 360, not 390. 360, and you divide by the number of lines of symmetry. And that makes it really easy. So the one on the left here is going to take 360, because 360 divided by 1 is 360. So it's 360 there on the left. The next one has 6, so 36 divided by 6 is going to give you 60 degrees. And the next one has 4, 360 divided by 4 is 90. And then 360 divided by, infinity is 0. And I'm just going to put greater than 0. If you do anything greater than 0, it's going to look exactly the same. And that's going to bring us to some triangle congruency stuff. You state whether the two triangles are congruent and explain how you know. Well, right here, there's the little reflexive property lets you know that that middle shared side is congruent to itself. And if you look at this left one, then we have 2 sides and the angle between them. If you look at the right one, we have 2 sides and the angle between them. So this one's going to be yes, and this is by side, angle, side. And we can do 14 and 15 real quick. What information is still needed to have congruence by the indicated theorem? Oh, we need to get side, angle, side. Right now, we have a side and a side, a side and a side. So we need angles. We need these angles to match up. And so we need angle ABC to be congruent to angle LMN. You could have also just written angle B congruent to angle M, but those are both ways to write it. So that one's or. And that brings us to 15. Right here we have some congruent angles, and then these angles right here, where we have these two lines across, these are also congruent because they're vertical angles. And now we have two angles, and we want angle, side, angle. We need the side between them. We need those to match up. So we need side LY to be congruent to LK. And there's the first 15.